Hello everyone. In this video, we're going to study differential. Um, in the previous study, we know that the derivative of a function y equals fx can be expressed by using the notation f prime of x or y prime or dy over dx. Now, in this video, we will see what is the meaning of these two terms, dy and dx. We will see what does each represent. Okay, here we have a graph of some function y equals fx. When x equals x0, the function value we can see is f of x0. And when x equals x0 plus delta x, where delta x is a small number, okay, the function value is f of x0 plus delta x. Okay. So the delta x we can see is the difference between these two x values. And the difference between the two function values, between the two y values, we use delta y to represent. So delta x is the amount of change of the x values, and delta y is the amount of change of the y values. Okay. And also at this point, x0, f of x0, at this point, I can draw a tangent line, okay, which is this red straight line. On this tangent line, when x equals x0 plus delta x, we can find this point. And the difference between the the difference between the x value of these 2 points, I use dx to represent. And the difference between the y values of these 2 points, I use dy to represent. So now we can see that dx is the same as delta x. Because both of them represents the amount of change of the x values of the 2 points. But dy and delta y, they are not the same. They are not the same. Okay. And also we know that the slope of this tangent line in precalculus, we can find this slope using the formula because the slope is equal to the ratio of the change in the y value to the change in the x values, right? Since the change in the y value, we use a dy to represent, and the change of the x values, we use a dx to represent. So the slope of this tangent line is dy over dx. And in calculus, we said the slope of this tangent line can also be given by using the derivative. It equals the derivative at this point. The derivative at this point x0. So now we find a formula for finding this term dy. So dy equals the derivative f prime of x0 times dx, which is the same as f prime of x0 times delta x, because delta x and dx, they are equal. Now we understand what does dy and dx represent. Dx represents the difference of the x values on the tangent line. Also, it's the difference between the x values on this curve. And dy stands for the difference of the y values on the tangent line. The difference of the y values of 2 points on the tangent line. And the formula for finding a dy is given by this. And if the delta x is a very small number, then dy will be a very good approximation to delta y, which is the actual difference of this of the function value at these two numbers. Okay. Now here is the formal definition of differentials. Let y be f(x) represent a function that is differentiable on an open interval containing x. The differential of x, we use a dx to represent, is any non-zero real numbers. And the differential of y, we denote as dy, is given by this. So to find the differential of y, we need to know two things. One thing is to know what is dx, which is delta x. So we need to know what's the difference between the point x0 and x0 plus delta x. And the second thing is to know what is the derivative at the point x. Okay. So how do we use this? In the previous example, we have seen, for example, if I wanna estimate the function value at some difficult numbers, like I wanna estimate the function value at x equals 4.5. So 4.5 would be this number, would be x0 plus delta x. Then I want to find an easy point. At that easy point, I can calculate the function value, and I can calculate the derivative without too much trouble, without too much work. So that number is x0. Like in our first example, the x0 is 4. So therefore, we can find delta x, and then because we're given function, so we can find what is the derivative of the function when x at that easy point, when x equals 4. And once we found the two things, we found the dy. So we found the approximation. We found the approximation of the function when x equals this difficult number, 4.5. Okay, let me do this example. Compare dy and delta y at the value x equals 2 for delta x equals 0.1 using the function fx equals x squared. So in this question, we are asked to find both of them and then to compare their value. So to find delta y, because delta y is the actual difference between the function values f of x0 plus delta x and f of x0. So now we need to evaluate what is the function value at x0 and what is the function value at x0 plus delta x, and then find out their difference. We're given that function is x squared and x0 is 2. So x0 plus delta x is gonna be 2.1. Here we are looking for what is the difference between f of 2.1 and f of 2, which equals 2.1 squared minus 2 squared. And 2.1 squared 4.41 minus 4. So delta y is 0.41. Okay, now to find the dy, we're using this formula. So dy equals the derivative of the function when x equals 2 and multiply by the delta x. So we will need to find the derivative first. The derivative of the function fx is 2x. So f prime of 2 equals 2 times 2. 4.1. So delta y is 0.41 and the dy is 0.4.